We're here at the Jerusalem College of Technology, also known as Machon Lev, speaking to Professor Michael Bank regarding his new approach for transmission of electricity. The conventional electrical transmission systems utilize two conducting wires for a complete circuit. Michael Bank explains how it's possible to use a single wire to transmit electricity. He calls it a single wire approach, the B-line system, as opposed to the A-line system. Professor Bank, do you want to tell us a little bit about your background? You come from Russia, you're not a native Israeli. St. Petersburg, right?
Yes, right. I worked in St. Petersburg in research institute, big research institute named Prof. Okay, after that I go to Israel. Now I work here and in other colleges in Israel. Okay, each day I study Hebrew because the English will not too good, but I think all will be clear.
So the term one-wire electrical system sounds a little bit unbelievable. Anyone who has learned the basic of electricity knows that two wires are required for a complete circuit. How do you explain that?
There are many systems in only one channel. For example, waveguide, fiber optic system, radio system. This is only one channel. And in electrical system, active power is not returned to source. Maybe it's possible in the electrical system to make one-wire system.
I saw in your journal article that one-wire systems were proposed many years ago. Also by Nikola Tesla, and there are also two patents in Russia and France that discuss the one-wire method.
Yes, you are right. Tesla first. Okay, after that from France, both system. After that, two brothers are running from Russia. But in all this system, there is a processing of electricity energy. Processing leads to loss of part of energy. We want to make system without losses, and for information, and for DC, and for high voltage. Okay? This is our dream.
Okay, can you explain in brief the basics of your proposal?
Yes, what this conventional two-line system, E-line, okay, we can see there is source, generator, there's two wires with opposite phases inside of this wires, and load, okay. It is possible to combine two wires, okay, because there are opposite phases or opposite polarity. But we propose this to use inverter, okay, in this line. After inverter, we have the same phases, the same polarity, but load also need two opposite phases, okay? We put it another inverter. Now generator and load see the same, like in the original system, okay? But this we have the same phases. This we have to combine these wires. Here we can see our system B-line, okay? We have only one wire. There is two currents. Yes, Paul, this milliampere, this 2 milliampere, okay? This is working, okay?
Okay, will your system work using other frequencies or voltages?
The result of one simulation, yes. This we use delay line for inverter, okay? Delay line for inverter, this delay line for inverter, where all currents correspond to ohm load. This milliampere, this 2 milliampere, this milliampere because the volt, the kilo ohm. Okay. This we use delay line. Delay line in real scheme, it's impossible to make. This will be 3,000 kilometers long because we use for transformer with opposite winding scheme.
In your scheme, you're saying that you're not using grounding, but isn't ground the second wire in your system?
Resistance between 2 points in ground very big. For example, 100 ohm for meter. It's much more than in wires resistance. It's impossible to transmit energy during ground. You ask about DC, no? Not?
Yes, before.
Before, yeah. And ask about DC. Okay, and in DC we can make inverter. Okay? This inverter can consist 2 capacitors, okay, which turn charge and discharge. In the transition from charging to discharging, the direction of the current changes. So we can the same potential here, and we can combine in 2 wires, in 1 wires. Okay, the same inverter we have in receiver part. Okay.
I understand that you tested the system using wires in the campus of Mahon Lev. Do you want to tell us a little bit about that?
Okay, can we make system in Mahon Lev? And what this room we have here now? Can we here now? Okay, we can wire on 300 meter in another building. Some we have lamp. Okay, where we have another wire. It goes to next classroom. Well, we can see in this classroom the bulb it's conducted by another wire. I can plug in 1 wire system. Yes. This wire also 300 meter. Okay. Where in this system it's no ground. It's no ground. We have here dividing transformer, okay, and 2 inverters. For 1 line to another building and inverters for next classroom.
How does the VLAN approach compare with the SWARE system, which also uses 1 wire extension?
Yes, this SWARE system also only 1 wire. Okay, there are 2 transformers. 1 important transformer we can connect to ground. When they connect to ground, we have to current, we have to energy in load. But in this system, we have a big part of energy losses. Okay, in this simulation, we see the generator give 40 milliwatt, a load receive 20 milliwatt. These losses depend on distance between this transformer. If distance more than 20 kilometers, there is losses of energy. In our system, no losses of energy. Okay?
And what about the 3-phase systems?
Oh, 3-phase is problem. The many questions about 3 phases. I think we can transmit 3-phase system during 1 wire V-line now. For example, we can take 1 wire and dividing in 3 wires, the same current this, but in 2 wires we can make phase changing by 60 degrees, plus 60 degrees minus by inductivity or by capacity. But we have to make 120 degrees. How we can use these inverters. That's why we have 3 phases equals 120 degrees. The 3-phase system by 1 wire only.
Okay, in brief, what would you say are the main advantages of your proposal?
Yes, we have some advantages. We can see for, first of all, reducing number of wires on the globe, extensive use underground power. We can use here underground power because there is only 1 wire. Reducing number of accidents, not accidents can between 2 wires, okay, only 1 wire. reducing loss in transmitted information by twisted pair, okay, reducing distortion in information transmitted in symmetrical line caused by an unbalanced influence because only one wire, okay, even developing cellular font without antenna, okay, that's our advantages.
What is the what is the advantage for using a single wire for underground systems?
That's a big problem today. You can see here in center of Jerusalem, I make this picture, okay? This high voltage system near from window, okay? It's not too good. It's not too good. We want to make buildings without this system. Yes, it's a good.
Okay, do you think?
Okay, if today we want to make underground system, we have make tunnels. We have only one wire. We don't need the tunnels. Only one wire, and so. But our dream this, instead of this system in many high voltage wires, okay, in big doors we have another system, only one wire, very cheaper, very beautiful, okay, like, and in electrical train, yes, today we have two polarity signal, one in wire, second in rails. Behind the rails we have a problem in straight currents, because this problem, they use some equipment, very expensive. In future, if we have only one wire, it's not problem this. It's no straight currents. In each home, in each flat, today we use 3 wires. In future, you only 2 wires. Okay. Today we have a corona effect between wires in high voltage. Okay. In future, no, not will be corona effect.
Very nice. I see that you're sure that you got it. So what is your plan? What are your next steps?
So today in many countries there are some unconventional source of energy. They need cheap electrical system to put this energy in center of the country. We propose this. That's, we know what we have to do. Okay, but we want to find investor or another firm which want to join venture. And we are ready to give all information which we know. This information we can find in this site, our site, all this presentation, articles, patents, yes, and by mail.
I wish you every success.
Thank you. This one wire flyer for you.
Thank you.